So in this last video, we'll deal with some of the questions that we kind of skipped over from before, like letter B. Letter B is not really a different problem. It just looks different because letter A and all the other examples we did had the word log in it, and letter B doesn't. But that's okay. Letter B is basically just the opposite. It's an exponential. So the same steps still apply. I still need to find an inverse. First step, switch x and y. So x equals 10 to the power of y. Now I need to get y by itself. This is where it helps, though, to understand what exactly is going on here. Because to get y by itself, I need to get rid of the 10. The 10 is currently exponentiating the y, so I need to get rid of the 10 by doing the opposite of exponentiating, which is logging. I need to use a log in this problem. So I'll build the structure here. I know I'm going to need log. And I'm going to build my little arrow here so that it helps me kind of see in what order I should build all these pieces. Let's see if we can translate this problem and put together the pieces like a puzzle. We know that the log base must have been 10 because the exponential is base 10, so that means a log must be base 10. Then when I think about this in exponential form, it must have been 10 to the power of y, so I know that the y must have been that thing on the other side. And then equals, I would have looped back around to the middle, equals x. So I'm going to read it back to myself and make sure that's what the original problem said. 10 to the power of y equals x. It says it backwards, but that's okay. We know it says the right thing. So we know we wrote it correctly, and notice something. Y is by itself. That's what we wanted. We wanted y by itself. So we're done. Y equals log base 10 of x. Now some of you may remember from our previous lesson that log base 10 is the same as a log by default, so a log by itself. You don't have to know that for this, it's just worth noting. If you look at the answer key and it just says log of x, that's why. It's because technically a log base 10, you don't have to write the 10. Now, let's see if we can apply this to other examples that also look exponential. As a reminder, letter B was exponential to begin with, and so is letter D, so is letter F, and so is letter H. So those will be the examples that I'll try here. In question letter D, same thing. Let's do the exact same steps. Switch x and y, and then get y by itself. So first step, switch x and y. Instead of y equals, we have x equals 10 to the power of, instead of 2x, 2y. There's my first step. Now let's get y by itself. Again, I'll ask myself, in the order of operations, what do I need to get rid of? I need to get rid of the 10, and I need to get rid of the 2. Technically, I can't divide the 2 yet because it's kind of floating up there as an exponent. I don't have anything to divide that looks like an exponent on the other side. So let's get rid of the 10 first. Let's see if that helps. 10 is currently exponentiating, so to get rid of it, I will use log. Remember, to get rid of an exponential, we use a log. I like to write the word log and then write very lightly that little loopy arrow so that I can see how to build my log into place. Now, let's think about the clues here. We know that the base must be 10 because the exponential was a base 10. Then it was 10 to the power of, so we knew the power was 2y. That tells us that 2y must have been over here on the other side. And then as I loop back around, it's always equal to whatever was left, so that's equal to x. I'll read it back to myself. 10 to the power of 2y equals x. Yep, looks good. So I'm looking at this and asking myself, okay, is y by itself? Ooh, not quite. But now it looks kind of easy. 2y, I can get rid of that 2. That's just dividing by 2 on both sides. That'll take care of it. So y is by itself, and now I know I have my equation for my answer. Y equals log base 10 of x, all divided by 2. Let's try another one just to make sure that the idea makes sense. Hopefully with some consistency here we can start to see a repeated pattern. Let's try letter F. In letter F we have 2 to the power of x minus 4. Okay, so first step, we switch x and y. I'll do this on scratch paper so we can see it. X equals 2 to the power of y minus 4. I'm going to try to go a little bit faster now so that we can start to see that these problems don't need to take a million years each time once you know what you're doing. Let's get y by itself. Can't get rid of the minus 4 yet because it's currently stuck in the power spot, and I don't have any powers on the other side to work with. So let's get rid of the 2 first. It's an exponential, so I know I'm going to need a log to get rid of it. I'll write my log, I'll write my little loopy arrow, and I'll fill in the pieces. Since the exponential was a base 2, I know we'll have a log base 2, always compatible. It was 2 to the power of y minus 4. So y minus 4 must be over here on the right hand side. And then as I loop back around, it's equal to whatever's left over, so that was the x. So there I have my problem so far. Log base 2 of x equals y minus 4. I have to get y by itself, so now I look back and say, okay, what else is near there? Oh, minus 4. Well, that's okay. I can get rid of minus 4. We'll add 4 to both sides. Now technically, log base 2 of x is one thing, and plus 4 doesn't have any like terms, so I'm just going to leave it separated like that to show that I did go through the motions. I did get y by itself. I just couldn't add any like terms. So my answer then is simply going to look like y equals log base 2 of x plus 4. Again, you might be looking at these and feeling like, oh, that makes sense, because it had an exponential base 2, or inverse had a log base 2. The original problem had a minus 4. Here we are with a plus 4. So a lot of things hopefully do make sense once you know what you're doing. Last one, let's just see if we can give it a try, and that's letter H. In letter H, same thing. Switch x and y and get y by itself. So if I switch x and y, the question will say x equals 6 to the y plus 4. Now let's see what we need to do to get y by itself. Can we move anything easily? Looks like we can move the plus 4. It's not stuck anywhere. It's just kind of free, ready to move. So I can subtract the 4 to the other side. Looking good. Now I want to get y by itself. Let's get rid of this 6. I know I need to get rid of something exponential, so I'll need to do log. Log, and with my little arrow here so I can fill it all in. Log base, we know it must have been a 6, because that was the exponential base. It would have been 6 to the power of y, so I know y must have been on the opposite side, equals, now the rest of it is the x minus 4. I'm going to put that in parentheses to just show that it's all together, but I don't really know what to make of it. The good news is I don't have to make anything of it, because y is by itself. That's all I wanted. I don't need to care what x minus 4 really is, because all I needed to care about is that y is by itself. So y equals log base 6 of x minus 4. It's definitely not an easy concept. I'll be perfectly honest with you. This is abstract for sure. Inverses are next level stuff. If it makes sense, that's great. And if it doesn't, don't fret too much. If you have a chance to try number 4, it's just another example, very similar to the ones that we were just doing. But if you feel as though this is basically overload for your brain, don't fret. Do as much as you can, make sense of whatever you can, and then move on. If at this point you feel as though it does make sense though, you're in great shape for math analysis, where you're going to use a lot of this inverse stuff again next year.